All right, everybody. We've been working on arithmetic sequences, meaning the pattern of numbers that all go up or down by a constant difference. So I'm going to do a couple problems in this video that are just number problems. Next video, do some word problems. And then video after that, we'll talk about series where you add up the numbers. So this one has an arithmetic sequence that we go 5, 9, 13, 17, dot, dot, dot. So what I want you to identify is what are the numbers changing by? How much are we going up by every step that we move to the right? A lot of times you're able to just calculate it by just kind of looking at it. If you ever can't calculate it, you can just subtract two consecutive terms, like 9 minus 5, or 13 minus 9, or 17 minus 13. You get a D of 4. There's two totally correct ways to write the general term for the sequence. We'll give it a name. Let's give it A. The nth term of the sequence is either 5 plus 4 times n minus 1. Or you could put the n minus 1 in front of the 4. It doesn't matter. The logic behind this is our pattern starts with 5 and it adds 4 over and over again. That's why the 4 is being multiplied, because you add multiple copies of 4. Why is it being multiplied by n minus 1? Because the pattern takes one fewer difference to get to the nth term than the number n. So let me show you what I mean. This is A1, this is A2, this is A3, this is A4. To get to A2, I added one copy of the difference. That's 2 minus 1. That's why there's an n minus 1 in the formula. To get to A3, I added the number 4 twice. That's 3 minus 1. To get to A100, I would have added 99 copies of the difference. To get to AN, I add n minus 1 copies of the difference. Maybe you don't like that. You can imagine what the value that comes before 5 is. It's 1, because I just subtracted. These two versions are equivalent. These two versions are the same. I don't care which version you use, they are both correct. You should also be able to understand and convert between the two versions. I want you to notice that if you distribute the 4 in the parentheses on the top version, boop, boop, you can see how it turns into the bottom version when you combine like terms. I'd also like you to remember that this version right here looks a heck of a lot like y equals mx plus b. I just wrote b plus mx for no real reason. All right, then that was part A, writing down the general term. Part B is asking, is 116 a term of the sequence? So I like to put a question mark. Is 116 a term of the sequence? You can use either version of the equations. I'll just use the first version because that's what you're going to see more often with arithmetic sequences. Solve it just by trying to get n by itself. So now I've got 111 equals 4 times n minus 1. Two options here. You can either distribute the 4 or you can divide both sides by 4. I like to divide both sides by 4 because now I can write down no. Wait a second. Now you thought I was solving for a number. I was answering a yes or no question. The question was, is 116 in the sequence? And I can say definitively no. How do I know that the answer is no? The answer is no because 4 does not go into 111. No, 111 divided by 4 is not an integer. It's not a whole number. So that's it for the first question I was asked about. Second question I was asked about is pretty similar. We've got an arithmetic sequence. We don't know much about it. We know the third term is 12, and we know the 10th term is 40. Well, what I know, just like I was talking about, is it takes a common difference to get from one step to the other. So if I have, say, 3, 4, 5, 6, 7, 8, 9, 10. 3, the third term is 12, the 10th term is 40, then it takes 1, 2, 3, 4, 5, 6, 7 steps to get to 40. In other words, the difference between 40 and 12 is 7 steps away. Notice what I just did is slope. I just did y2 minus y1 over x2 minus x1. 40 minus 12, 10 minus 3. The two values in the sequence are 28 numbers apart, and it took 7 differences to get from the third value to the 10th value. So 28 divided by 7 tells me that 4 is my common difference. Now I want to find the first term. Well, we can just go backwards, because we were at term 3. So 3, 2, 1. So you can see that the first term is 4. Other way to do it is to say that the first term plus 2 differences is the third term. This should make sense. First term, 2 steps to the right gets you to the third term. So we know that u1 plus 2 times 4 is 12. Notice how you solve that. You subtract 2 times 4. That is exactly what I was showing you with the arrow. You're subtracting 2 arrows from it. So you get u1 is 4. Now we're going to find the 100th term. So to find the 100th term, we use the information we have. It's going to be the first term plus 99 copies of the difference. It takes 99 steps to get to the 100th value. So that means that u100 is going to be 400. There we go. All right, so that's it for just some arithmetic sequence problems using numbers. Next video is going to be word problems. Please comment. Let me know if anything's confusing.